Let's continue our studies on rationals, and we're going to look at solving rational equations. And just like we've done in the other lessons, let's look at rational equations that we are familiar with, like just dealing with fractions. So on your warm-up review right here, we've got an example of an equation that is full of fractions. And I don't know about you, but I hate fractions in my equations. And so I'm sure you're looking at this too, and you're like, oh my goodness, that's a lot. Well, you may or may not know there is a great way to solve this to get rid of the equations to make it so much easier. So we can take our problem, x over 16 minus 1/2 equals 3/8, and we can think about what our LCD, or our least common denominator, would be. Least common denominator. And so for 16, 2, and 8, least common denominator, so we want the smallest common denominator they would have in common. So I'm going to have to make some of them bigger so that they are common. So we are going to use a least common denominator of 16. So 16 is the smallest multiple that they have in common. I can make 2 into a 16 by multiplying by 8. I can make an 8 into a 16 by multiplying by 2. So our least common denominator, LCD, is going to be 16 for this problem. Now, to make this problem easy for us, let me copy it over here. If you take your LCD, 16 for this one, and you multiply every term in your equation by 16, you're going to make it ugly, but then it's going to clean up so nice and pretty. Let me show you. So for the first term, now it is 16x over 16 minus 16 over 2 equals 16 times 3 is 48 over 8. So I made it ugly, but just wait. Look, if I now simplify those new numerators with the denominators, now it's 1x minus 16 divided by 2 is 8 equals 48 divided by 8 is 6. Wow, that big messy equation, when I multiplied every term by the LCD, it's now x minus 8 equals 6. Some of you could solve this in your head now that it doesn't have fractions. So that's rational equations. Obviously, algebra 2, we are going to do have polynomials in there, but that's going to have the same concept. We are going to use an LCD to multiply every term to simplify our equation so we can finish solving it. So let's look at our notes. It says a rational equation contains at least one rational expression, aka a fraction. So for it to be a rational equation, there's a fraction in there somewhere. You can simplify solving a rational equation if you first clear the equation of the denominators. You can do this by multiplying the LCD of the rational expressions in the equation, modeled above. So let's look at our steps. Step 1, identify the restricted or extraneous values for x. So to do that, set the denominator or denominators equal to 0 and solve. So this is a big concept. I'm going to make sure that we really lay an awesome foundation for these types of problems. In Algebra 2, a lot of times we will do a great job solving, we will get answers, but then they don't work when we plug them back in. So this is one of those scenarios where we are going to identify restricted, like I can't have this answer, or they're also called extraneous solutions. And I have a definition there below. Restricted values are any values that are going to make my denominator 0. Why is that a bad thing? You can't have a 0 in the denominator. The world explodes. Just everything implodes. Whatever you got to tell yourself, you cannot have a 0 in the denominator. Bad. So you can see in our examples below, 1, 2, and 3, I can see right now, we've got x's in the denominator. So any kind of value that I plug in for x, where it's going to make that denominator 0 is bad news. So we don't want those. So we'll identify those as we're getting started to begin our problem. Step 2, factor those denominators to help us find that LCD. Step 3, like I modeled above, once we found the LCD, we are going to multiply each term in the equation to help us get rid of our denominators. And step 4, clean it up, distribute, simplify, and solve. And then last step, check When we made that list of extraneous values, did we get any of those as our solutions? So checking for those. All right, number one, first thing, identify those restricted values. So I'm going to list those over here to the right of my problem. So looking at my denominators, I've got a 6, I've got an x, and I've got a 6x. So a restricted value is anything that's going to make my denominator 0. Well, I don't have any problem with the 6. But in the second one, where there's x, when I finish, x cannot be 0. If I end up with a final answer of 0 and then I go to plug it in, automatically my denominator is 0. And the same is true for the last one. 6 times 0 makes 0. So the only restricted value we have on number 1 is 0. When I finish, I cannot have 0 as an answer. If I do, I'm tossing it out. Now let's find our LCD, our least common denominator. Our denominators are 6, x, and 6x. Think back to the problem at the top. We had 16, 2, and 8. We had to make some of them bigger so that they would be in common. So we're going to do the same thing here. My common denominator is going to be 6x. I'm going to need to beef up the 6 to make it a 6x. I'm going to have to make x into 6x, but I can take all those factors of the denominators and build a 6x. Take 6x and we're going to multiply each term by 6x. I'm going to rewrite my problem here below. And now I'm going to take that LCD 6x and multiply each term by 6x. All three of those terms. We have 3 in our equation. In the first term, the 6's will cancel out and leave me with negative 7x. In the second term, the x's will cancel out and leave me with plus 6 times x plus 1. And in the last term, the 6x's all cancel out and we just have 1. Look at now, it's not a rational equation anymore. It's just an equation. So step 4, we're going to distribute, simplify, and solve. So let's see what happens. We've got distributive property. Then we combine those like terms. Negative 7x plus 6x makes negative 1x. Subtract 6 from both sides. And divide by negative 1 gives us x equals 6. Now, before you circle it, before you put it in Delta Math, whatever you're going to do with it, double check. At the top, we listed restricted values. I could not have 0. I got a 6. We are good. X equals 6. Number 2. First, let's see. What would be our restricted values? Looking at my denominators, I have an understood 1 in the first term. I've got an x and I've got a 3. So when I finish, I cannot have a 0 because when I plug in 0 for x, world it explodes, right? So restricted values, when I finish, x cannot be 0. Let's find our LCD. Again, we have that understood 1. We've got an x and we've got a 3. So sometimes we have to make our denominators bigger so that they are in common. So taking each of those, bring them together, our LCD will be 3x. I'm going to rewrite my problem below to show you all the steps. We're going to multiply each of those terms by 3x. The first term, it just gets multiplied together, negative 6x. In the second term, the x and the x in the denominator cancel, and I'll have 3 times 8 is 24. And in the last term, the 3 from the LCD and the 3 in the denominator cancel, and we have negative 8x. Pretty equation, no fractions. So let's get to solving it. I am going to add 6x. Since my constant 24 is already on the left side, I'm going to move all my variables, my x's, to the right side. So I'm going to add 6x to both sides. So it says 24 equals negative 2x. Divide by negative 2, and I get negative 12. Checking with my list of restricted values, I was not allowed to have 0. We got negative 12. That's a good answer. Number 3, first, what would be our restricted values? Answers that we can't have because they make the denominator 0. My first denominator is x plus 5. Second denominator is understood 1, and then another x plus 5. So if you ever need help with this, in the notes on the steps, it says you could set it equal to 0 and solve. So when I subtract 5 from both sides, I see if I got -5 and I plugged it in, -5 plus 5 would make 0, and it would make the world explode. So we cannot have -5. So when I finish solving, if I get -5, toss it out. What about our LCD? So we're going to get rid of these fractions, multiplying by our LCD. We've got x plus 5, the 1, and another x plus 5. So yes, you can use just x plus 5. That'll work. Rewriting our problem here. Now let's multiply everything by that LCD, x plus 5. My LCD and the entire denominator in my first term cancel out, leaving me just with an x. Nothing cancels in the second term, so you are going to have to multiply with distributive property there. And the last term, the LCD and entire denominator cancel out, and voila, no more fractions. Let's finish solving, doing that distributive property. Combining those like terms. Solving our two-step, adding 25 to both sides, -4x equals 28. Divide by -4, x equals -7. Now, what was my restricted value? Can I have a -7? Yes, restricted value is -5. So -7 is a good answer. Moving on. All right, page 2. Everything's going to really get to rocking and rolling. Our first 3, in all honesty, was getting us warmed up, getting us comfortable. Let's see what happens on these last 3. So first of all, restricted values for number 4. X cannot equal, let's see, understood 1, and then we have x minus 6 and x minus 6. So x could not be positive 6 because 6 minus 6 would make 0 and the world would explode. LCD, you got a 1, you got an x minus 6 and an x minus 6. Common denominator is just 1 x minus 6. Rewrite our problem here. Multiply everybody by that LCD, x minus 6. In the first term, there's no denominator to cancel out, so we will have -8 times the LCD, x minus 6. Second term, the entire LCD and denominator cancel out. And in the last term, entire LCD and denominator cancel out. Beautiful equation, no more fractions. Distribute. Combine like terms. -7x plus 48 equals 6. Solve the two steps, subtract 48. Divide by -7. X equals positive 6. Wait, hold on. This sounds familiar. At the top, restricted values? I wasn't allowed to have a 6. 6 makes the world explode. So what do? We toss it out. So cross that one out. We cannot use it now. That means formal answer is no solution. If you're on a benchmark, EOC, and your answer was a restricted value, your ABCD formal answer, mathematical answer is no solution. On Delta Math, you will leave it blank. Leave blank on Delta Math. Number 5, restricted value. X cannot equal, let's see, we've got x minus 8. And then look at this other one. Go ahead, you might want to go ahead and factor your denominators. I think it's listed as step 2, but sometimes it helps us see what else we've got going on. So that second denominator is actually factored as x times x minus 8. And then, of course, we had the understood one. So x cannot equal 0, and x cannot equal 8. You see that? So we actually have 2 restricted values, 0 and positive 8. What would be the LCD for this problem? Remember, sometimes we have to make them bigger. We got to make sure to include all of our denominators. So we will use x and the x minus 8. For the first term, the denominator was x minus 8, so now we just need to multiply it with an x. The second term had all of those factors, and the last one needs all of those factors. So we are going to use x times x minus 8, and I'm going to leave it in that factored form to help through the simplification process. So I'm going to rewrite our problem, and I'm going to rewrite it with that factored denominator again to help me as I'm canceling with my LCD. Multiplying each term by the LCD. In the first term, the LCD, the x minus 8 part and the denominator cancel out, and we have x times 8x, or 8x squared, minus. In the second term, entire LCD, entire denominator cancel out and just leave us with minus 1 equals, nothing's canceling, so we've got to multiply all of that together. I'm just going to show that as negative x times x minus 8. We will distribute that if you want to go ahead and do that. So let's see, 8x squared minus 1 equals, distributing, I get negative x squared plus 8x. You have x squareds. Those are quadratics. All right, so let's move everybody to one side. Let's add the x squared to the other side. So we have 9x squared. We are going to put this quadratic in standard form. Subtract the 8x to the left side. There's no like terms over there, so just write them in order of standard form. Something x squared plus something x plus your constant now equals 0, right? Because I subtracted the 8x. Okay, so you have a quadratic. Now what? You have a quadratic, you're going to factor it, then you're going to solve it, taking our factors, setting them each equal to 0, and getting answers, okay? I'm going to try to factor. I've got a leading coefficient of 9. I'm going to multiply 9 and negative 1. I'm going to find the factors of negative 9 that add up to the middle, the negative 8, to help me factor by grouping. We're going to need a negative 9 and a positive 1. So rewriting my middle term as negative 9x and positive 1x and using grouping. Group. First group, GCF is 9x, and we have x minus 1. Second group's GCF is just a 1, x minus 1. Rewrite our binomials, 9x plus 1 and x minus 1. Now solve each of those, set each of them equal to 0. Subtract 1 from both sides. Divide by 9. X equals negative 1/9, and x equals 1. Now, what were my restricted values? My restricted values were 0 and 8. My answers were not either of those. So negative 1/9 and 1 are good answers. Neither got tossed out. Number 6, last one, restricted values. X cannot equal, let's see, our denominators understood 1 and x plus 1. And here again, you might want to factor. We can pull out an x and have x plus 1 for our third denominator. So x cannot be 0. And for the x plus 1 piece, x could not equal negative 1. So our restricted value is 0 and negative 1. If I get either of those, toss them out. What would be our LCD? Again, we're going to have to go bigger so everyone can be included. GCF, or LCD, is going to be x times x plus 1. Rewriting our problem, and I'm going to rewrite the third denominator in factored form. Multiply each term by your LCD. Okay, in the first term, nothing's canceling out, so all of that gets multiplied together. You can just write it the way it is and then distribute, or we can go ahead and distribute as we write it. X squared plus x is that first term, plus In the second term, the x plus 1 from the LCD and the denominator cancel, and we have x times 5x, or 5x squared, equals the last term, entire LCD and entire denominator cancel, equals 5. So let's see what we've got. Like terms, we've got 1x squared plus 5x squared is 6x squared plus x equals 5. Again, we're getting another x squared, so another quadratic. Let's put it in standard form, move everybody over to the left side, so it's 6x squared plus x minus 5 equals 0. Write it in standard form. Try to factor it, so let's multiply 6 times negative 5. Factors of negative 30, that add up to a 1. 6 and negative 5. So rewriting my middle term for grouping. Grouping those first half, second half. GCF first group 6x. Second group a negative 5 gives us another x plus 1. Rewrite your binomials 6x minus 5 and x plus 1. There's your factored polynomial equation. Finish solving by setting each of those equal to 0. I'm going to add 5 on the first one and divide by 6. X equals 5, 6. Second equation, subtracting 1 from both sides gives me x equals negative 1. Hold on. What were the restricted values? The very top, x could not be 0 or negative 1. Wait. I just got a negative 1. Uh-oh. Cross that one out. Restricted value. There's only one answer here. 5, 6. So that is solving rational equations. Always think and refer back to the very beginning where we looked at just the equation that had fractions in it. And we cleared out those fractions using a least common denominator. We did have to make our denominator bigger. On the example, we had to make it 16. So sometimes you have to use all the pieces from your denominators to make a larger common denominator so that it will help you cancel out. And so you don't have any more rationals in your equation. You don't have any more fractions, and then you just solve it. Our first 3 were pretty linear, very straightforward equations. On number 5 and number 6, we ended up with quadratics where we had to factor and then finish solving. Notice on number 4, we had a restricted value as our answer, so it was all tossed out. No solution for Delta Math. You leave that blank. Watch out for those restricted values, guys, when it comes to benchmark, when it comes to EOC. Those highly missed questions are where students have solved, and they have solved so well, but they didn't go back and check to see which answers actually get thrown out. So watch out for those, guys. I will try to remind you of that because that is always the tricky part, is just make sure your answers aren't restricted values that need to get thrown out. So let me know if you have questions. I'll see you later.